In 2015, they did a Kickstarter campaign for a smart camera based on a microcontroller. The campaign was a huge success and they raised over $100,000. But then came a disaster that they were not prepared for. One of the components in the smart camera failed and 80% of the cameras they had built were unusable. But they fought back and they delivered the cameras. This is the amazing story of OpenMV. And in this episode, we will learn what are microcontrollers, what are the challenges of porting computer vision algorithms to microcontrollers, and why do microcontrollers matter? But above all, we will learn the amazing journey of a resilient entrepreneur, Kwabena Agyeman, who is one of the co-founders of OpenMV. Welcome to the show. This is our podcast, AI for Entrepreneurs, and I'm your host, Satya Mallick from OpenMV. So welcome to the show, Kwabena. It is an honor to have you on the show. I'm really pleased that you could make the time. And it is a show for entrepreneurs, and who could be a better entrepreneur in AI than yourself? You have such great stories to share with us. So before we dive in, I would like to know a little bit more about the OpenMV project. It is a very popular project, but still there are people who may not know about it. So you can start by a little introduction and then start with the OpenMV project.
Yeah. So hi, I'm Kwabena Agyeman. I am the co-founder and president of OpenMV LLC, and we're a tiny two-person startup that's run in our free times because both me and my co-founder have day jobs, where we are basically developing computer vision algorithms that run on a microcontroller. This is a little bit different than OpenCV because we've had to tackle both the data input problem of interfacing with a camera and then storing said data and DRAM interfacing and such, attaching that to an SD card to save that data, and then also doing the vision processing algorithms and then driving IO pins. So it kind of encompasses the full compute stack, but the goal was basically to raise the bar for embedded compute for computer vision. So when we started, no one had the thought that you could run an algorithm like April tags and April tag detection on a microcontroller with less than 1 megabyte of RAM. But we demonstrated back in 2017 actually that that you could actually run April tags on a microcontroller with 512 kilobytes of RAM.
Wow.
And the reason this kind of stuff is cool to research and develop and kind of bring to the forefront is that if you really want to see a world where computer vision is a commodity and it's really embedded in everything, like every single light switch in your house has a camera that just tracks you and turns on the lights when you walk around. Yay, big brother, but maybe not. Maybe these things just throw away the data immediately.
Yeah.
We can only get to that future if we really work on how do we make our computer vision algorithms super embedded and run on very, very cheap hardware.
Okay, that's cool. So for people who are, not familiar with embedded vision and embedded systems in general, can you just describe the difference between what is a microcontroller versus, let's say, a system on a chip, like a Raspberry Pi kind of situation? What's the difference between the two?
Yeah. So it's kind of gotten blurred now, to be honest, but the basic way it worked was microcontrollers were essentially little processors that have a limited amount of IO, a limited amount of RAM, a limited amount of flash on board, and they were designed to do one thing in life. So a microcontroller might be designed to spin a motor, for example. It would look at you would look at current and voltage on a motor. Imagine there's these things called ESCs that we often see that are used for quadcopters. And so those have a microcontroller on them, and they basically take a servo input and then spin a motor. And so it's a little computer, it's executing code, and its one job in life is read that servo input and then spin a motor to match that servo input. And whereas when you talk about a full compute system like a Raspberry Pi or a Linux PC, this has a whole suite of software designed to really do anything.
Right.
But that extra flexibility adds cost, size, complexity, and really reduces your ability to deploy it as a cheap, less than $1 kind of device for doing one job. It's more
Right.
powerful, sure, but it actually gets away from that whole one specific purpose in life goal.
Right. So, do the microcontrollers have an operating system like all these, or uh, they're completely programmed in a different way?
So typically microcontrollers don't come with OS. They don't have something called virtual memory.
Yeah.
So you can, I mean, they have a processor. The processor executes code just like a regular other processor. But there's a fundamental difference in that they don't have something called a memory management unit.
Okay.
And this allows you to virtualize your different processes such that the kernel is separate from all the other applications running on board. And each application then gets its own separate 4 GB or 64-bit memory space to play with. On a microcontroller, everything is all running at the same time. There's no process separation. And
Got
because of this, there's no real concept of loading dynamically different software from other people that's
it.
in
Mhm.
a precompiled format. Typically on a microcontroller, you compile a binary image for it, which is the whole system that you want it to run. And then that is flashed onto the system and it will execute that code and only just that code.
Got it. Got it. So, I mean, the OpenMV Cam, could you explain the various components of the camera itself? What does it have? There's the camera, the processor, etc. Could you give some details? And how does it compare to some other systems? Let's say camera attached to a Raspberry Pi Zero.
Yeah, yeah. So this is the OpenMV Cam. This is our first popular version, which is the OpenMV Cam M7.
Hmm.
And so the system really is effectively just one chip.
Yeah.
That's the important thing to note. So there's a few other things like voltage regulation over here, some crystals and capacitors and whatnot, and there's a SD card slot, and then there's a camera chip beneath this lens.
Yeah.
But realistically, though, like this is the new H7 that we made back in 2000. We launched this in 2019, no,
Uh-huh.
18, I think. And it really, though, is effectively one chip. So what we've tried to do is stay away from having SD-RAM and flash on board the system because the goal is effectively to shrink it down to a small size.
Uh-huh.
We were going to launch this new product in the future called the OpenMV Cam Micro this year, but COVID happened and things
Oh,
have gotten delayed.
right.
But an example being that when you shrink, when you can run code on a microcontroller, let me
Right.
see if my webcam will focus on this.
Yeah.
You can shrink the whole. Hold on, it was almost there. Is it going to do it? You can shrink the whole system down to this is the size of a quarter. So if you here's a
It's
micro
tiny.
SD card.
Yeah.
Um,
Wow.
yeah,
That's
we've effectively shrunken the whole system down to, yeah, there we go. It's now it's in focus. So
Yeah.
you see that thing on the top? That's a 2mm by 2mm camera. It does 640 by 480. We
Wow.
have the processor in the center, which is 7mm by 7mm.
Uh-huh.
As you can see, it's the size of a USB, a USD micro connector.
Yeah.
And then we have a 4-pin JST connector on one side.
Okay.
And on the back, we have the IMU and a whole bunch of passives for power control and crystals.
Right.
But the idea is, by experimenting with, these one-chip type solutions, we can kind of move towards a future where you can have a one-chip / camera setup where this is a small embedded device which is designed to do one thing in life,
Right.
and nothing more. In terms of like the difference between a Raspberry Pi camera module, we're working with a lot less pixels generally, just because we don't have the SD-RAM to play with.
Yeah.
We did make a version called the OpenMV Cam H7 Plus, where we kind of reduced these constraints because people kept asking for higher resolution. So we
Uh-huh.
did add SD-RAM to the system. But the general goal, though, is to kind of like design a full compute solution that just runs on one chip with internal SRAM.
And the software stack for all these different solutions, it's the same. The software is exactly the same.
Yeah, yeah. So OpenMV is based on basically the idea got started. The OpenMV Cam comes from a long lineage of sensors called the CMU Cam.
Uh-huh.
This was created back in 2002, 2001 by Anthony Rowe. And it's basically it was a color tracking sensor where someone strapped a
Right.
microcontroller onto a camera And it had one job it could do. It could, literally threshold the image by looking for color thresholds. And then it would output a very simple centroid calculation of all the pixels in the image. It was very limited, but it actually sold quite well back in the day because it was the first cheap computer vision system back in 2001. It kept getting revved. Eventually, there was the CMU Cam 4 that I helped build in 2012 or so. That was
That
kind
was
of
a color.
yeah.
That was a color camera.
Yeah, a color camera.
Yeah.
And then you may now see it still as the CMU Cam 5 or Pixie sensor on the market. It's more or less maintained the concept of being just a straightforward color tracker, and it's a good solution just to get started with computer vision. What I came in with the OpenMV Cam was the idea that we wanted to add a little bit more functionality to the system, and in particular, add in the ability for it to be programmable. One issue with the CMU Cam is that it typically is faster than the microcontrollers you tell it that you use it to control, that are controlling it. So typically the CMU Cam would be attached as a secondary sensor to one device, and then that device would tell the CMU Cam, look for this color, and then the camera would respond with, this is where that color is at. Of course, the problem is now you have this huge communication layer stack that you have to run in order to share that data. And so the idea of the OpenMV Cam was it's easier to have richer, more complex data being used internally if we can kind of get that all on one chip. So if we had the ability to do IO pin control, basically think, plan, and act on the same chip versus two chips doing the same thing.
Right.
And so the OpenMV Cam then, in order to make that possible, we actually leveraged something called MicroPython, which we've been using from the beginning. And so MicroPython is this really interesting project where a guy named Damien George basically got Python 3 running on a microcontroller. And yeah, just to understand this, this is more or less all the cool stuff from Python 3. This is the full language spec, not like all the extra crazy features, but more or less, 99% of everything. And he got that running on board a microcontroller with basically 32 kilobytes of RAM.
Wow.
And, let's say 256K of flash.
Wow.
So, this whole executable and the whole virtual environment to run a Python interpreter fits into an incredibly small size. Oddly enough, if you take the MicroPython executable and put it on Linux, it actually outperforms CPython for many applications.
Wow.
Yeah.
That's news to me. I did not know about that.
Oh, yeah. Well, it's like, for example, CPython natively stores integers as these big numbers that can be variable sized. It doesn't use the concept of optimization for, if you're storing a variable that fits in 32 bits, only use 32 bits to store it.
Right.
CPython stores an integer as literally a class that can have flexible bits, and the number of bits can be unbounded. MicroPython does tricks like when the integer is less than 32 bits, it stores it in a machine word of 32 bits in length, and then tries to use the actual processor's built-in instructions to edit that, to add numbers together so it can go very quickly versus emulating arbitrary bit width math like CPython does.
Right. So MicroPython, there are some limitations, right? It's not like you can use any external Python library and it will work.
Yeah. So MicroPython, hold on for a sec. My AC just turned on and it's quite loud. So MicroPython is, need some way to turn these things off so they just don't go.
You can use a microcontroller to turn that off, using a voice command.
Yeah, no, I can. It's Alexa controlled, so I could just do it via that. But it's just aggressive. I have the Nest thermostat, and they really advertise it's supposed to have a lot of intelligence, but
I don't think so.
It always turns on whenever the temperature is the temperature is good. I don't want it to turn on, and it just turns on all the time. It would be smarter if it could figure out if I'm uncomfortable and then turn the AC on based on that.
Right.
That'd be a much better signal. Anyway, so MicroPython does have limitations. It doesn't really run all of the external libraries that Python comes with. But it provides a very easy development environment experience for Python programmers to program a microcontroller. One of the best features of MicroPython is that as long as you keep your program small, you can write literally Python code that runs in the microcontroller.
Right.
And compile and load time is very quick.
Nice.
This is an important thing to understand because with OpenMV Cam, we're using the highest end microcontrollers on the market. And
Mm-hmm.
so these have about 2 MB of flash.
Right.
And 2 MB of flash doesn't sound like a huge program, but microcontrollers, when you program and erase that flash, there's no like, so when you're writing data to like an SD card or in various different compute systems and moving data around, your operating system does this fancy thing called caching, where it'll store writes that you're actually doing in RAM and not actually perform them immediately in
Yeah.
order to give you the appearance that your hard drive is fast.
Mm-hmm.
Microcontrollers don't do that kind of thing for you. So when you actually write directly to the medium, it might take on the order of a good minute or two to write 2 MB of flash. And the reason that's a hassle is that if you were updating a program repeatedly and like changing one line of code,
Uh-huh.
you would incur like a 2-minute penalty to rewrite the flash per line of code you changed.
Right. Right. Right.
With MicroPython, all of a sudden that's reduced to less than a second for compile, load, and execute.
Oh, that's super nice. So what does the, suppose somebody gets the OpenMV Cam and they want to implement, so there are a few routines that come with the library that you have written, right? There, what can it do out of the box?
Yeah, so I would say first, our goal so basically with OpenMV Cam, we got this project started with a Kickstarter,
Okay.
and that turned into a burning trash fire immediately.
We'll come to it. Yes, I have heard about that.
Yeah, and because of that, we really had to scramble to like add features to like hopefully keep the project alive. Um, there was a goal in the beginning that it would be, very similar to OpenCV. Like we tried,
Uh-huh.
copying a lot of the features from OpenCV, but generally what we ran into were memory constraint limits.
Yeah.
We're on our third generation processor now, so we started with the Cortex M4, and then we moved to an M7, and then an even stronger M7.
Mhm.
But a lot of the limitations on how the library was designed were based on that M4, which had significantly less RAM than we currently have.
Yeah.
Um, More or less, what it came down to is we have a computer vision library. It's not as full featured as OpenCV, but if you are a actual practitioner of computer vision and you understand how like binary image processing works or just general purpose image processing, you'll find that most of the stuff we have on the OpenMV Cam mirrors exactly the kind of functionality you'd expect to find in OpenCV. We've taken a little bit of the liberty to mix and match things, though, in order to save RAM.
Of course.
So one of the things that OpenMV Cam does is OpenCV, for example, will typically store images as 32-bit floats
Yeah.
per color channel. And that's very good for having the best accuracy per pixel and being able to do really nice mathematics.
Yeah.
It is bad, though, for image size.
Right. Right.
So what our algorithms typically do is we actually have 3 copies of the same algorithm pretty much for every function that operate on a 1-bit per pixel binary image, a 1 byte per pixel grayscale image,
Mhm.
and a 2 byte per pixel RGB 565 image. And we have also support for Bayer pattern images too. And
Okay.
so will actually, in order to save RAM, they operate directly on the underlying image data structure that's stored that way. So, for example, if you want to perform morph operation, like if you want to multiply a RGB 565 image
Mhm.
by a smoothing kernel, our library will just automatically handle unpacking those pixels while it's doing the operation, then repacking them and storing them. This is all done to save RAM.
Of course.
Anyway, I mentioned that segue because it's not OpenCV, exactly generic,
Yeah.
command to command.
Yeah.
But if you understand computer vision, it's really not a leap and jump. Like pretty much the same kind of stuff we have on our system
Yeah.
is what OpenCV comes with.
Right.
Anyway, so as for how you can work with the library, we have 2 ways of programming with it. So there's a lot of customers who never email us and only meet them randomly in person. They're typically pretty silent, but what they'll do is actually directly take our C code and modify it to meet their needs. And these customers are typically folks who are pretty hardcore C programmers who know how to operate on image arrays directly and aren't afraid to write code.
Mm-hmm.
And then otherwise, we have a Python level interface where you can kind of use the built-in features of our library. And the kinds of built-in features that really help move the product and that make it popular are things like we have built-in QR code detection and decoding support, built-in data matrix detection and decoding support, built-in barcode decoding support, courtesy of the ZBAR library, and built-in April tag detection and decoding support. And then recently, we just added a new feature called TensorFlow Lite for microcontrollers. And so TensorFlow Lite for microcontrollers effectively is the full TensorFlow implementation on microcontrollers. Well, let me not say full. Many of the most popular features ported to a microcontroller, albeit the limitations of memory and etc.
And that's where TinyML also comes into play.
Yeah. This is where I'm part of the TinyML group. And so this is where a lot of people are interested in this new domain. An example of what we can do on board the system is we have the ability to run a person detector at about 6 FPS on the processor using MobileNet. I think it's MobileNet V2 that was trained on a data set of around 50,000 images of people and no people. And so right out of the box, the camera will be able to execute this neural network that'll literally tell you a binary yes or no. Is there a person in the scene or is there not a person in the scene? And just using that data, there's all types of applications you can make. Like, do you want to make a light switch that turns on when a person walks in? Do you want to make a door that just swings open when a person walks in? And that will actually all run. You can do that person, no person detection on the OpenMV Cam Micro, again, which is the size of a quarter, and will draw about 100 milliamperes of current at 3.3 volts.
So 100 milliampere means you can actually power it using the coin battery for how many?
You can use it with coin battery if you keep running it constantly, not for long. But the idea is that you would power cycle the thing. You would power cycle the sensor. A basic example would be, because the OpenMV Cam has no operating system and it's loading your program from Flash, there's no penalty to cutting its power anytime you choose. There's no hard drive to corrupt. The benefit for that is you can have another low power microcontroller with a Wi-Fi radio, for example, connected to our system. And that low power microcontroller can basically look with a motion detector sensor, like a PIR sensor. This motion happen, and if that happens, then turn on the camera, take a picture, get the analysis, and then power cycle the camera off.
And you have also built an IDE, which is very easy to use. You can actually run your code right there and see the effects it's having. Plug this camera using a USB cable and see the results pretty much immediately.
Yeah. So one of the goals with OpenMV was to kind of provide an Arduino-like experience. So OpenMV gives you all the power, but it's still command line. Basically you are operating with, you can launch open the GUI tools and such, but you still have to kind of build that for a complex application. And a lot of times you may not care to spend that effort. And so with OpenMV Cam, the IDE kind of takes care of the front end displaying of what the camera sees. And then with the IDE, you can just kind of write code to focus on giving the camera the ability to perform the operations you want. Like if you want to take a picture and let's say execute the median kernel on it to do median filtering on that image, followed by some type of binary image filter and then erode and dilate. You can write that in 4 lines of code and then add it to our script, our default scripts that the IDE outputs. And then you'll be able to see that effect happening on the camera immediately and not really have to worry about building up all of the communication environment to stream that image data to a PC and etc.
And you also have, the IO pins, which you can use to control, the output can be used to control other things like a light switch or something like that.
Yeah. So an example being on the micro, which I really want to get around to launching this year. Hopefully at the end of the year, maybe we can do a production run for it. So many other things in flight, but A basic example, like the default OpenMV Cam has 10 I/O pins,
Uh-huh.
and so those 10 I/O pins allow you to do SPI bus for high-speed communication from one device to another, a UART, the CAN interface for CAN communication, which is a very reliable protocol that cars use to communicate internally.
Uh-huh.
And you can also do PWM output on I/O pins, interrupt triggering on high-low edge events.
Right.
Servo control, pulse width measurement. We have an ADC pin to read I/O, to read analog I/O, and a DAC to output analog voltage. And finally, I think what's the other one? Oh yeah, I squared C for communication to like a serial, which is a serial bus, which you can have multiple devices hanging off of.
Right.
And what's nice about all this stuff is we just finished a interface library for the OpenMV Cam, which really turns it into a sensor that is, it's unlike any other camera sensor you've messed with. So with our I/O interface library, it's possible to set up a OpenMV Cam as an I2C slave device. And then you can have, literally using two wires, multiple OpenMV Cams all sharing the same data bus going back to one master unit that could be commanding and controlling them. So for example, you could have a Raspberry Pi that talks to 10 OpenMV cams at the same time on a robot or another system. And those 10 OpenMV cams could all be doing different things and then relaying that data back to the Raspberry Pi.
Right. Yeah. So that makes it so much more interesting, because once a robot has multiple of these, you could each could be doing different things, but even if they work together to do a single thing, it's very useful. Coming to robotics and drone applications, some people are building some really cool applications on top of. I heard that there is a company that uses your April tag detector for landing drones. Tell me more about that.
Yeah. So, I mean, basically, some folks wanted to land a drone more precisely. And so basically, our system can detect April tags. I can't say like we have the perfect Python level API for it, but I mean, again, a lot of folks just take our C code and modify it to whatever they need. But we actually have April tags too, the implementation that is like you can download from online. And we actually ported that to the system. And so using the April tags 2 algorithm, you will actually get a tag, and we perform all of the necessary image matrix calculations from the camera sensor to actually give you the exact distance, the translation in XYZ and the rotation in XYZ of the tag in 3D space. Once you have that information, you can then do that April tag detection on a high resolution image. So our system can handle, we have the OpenMV Cam H7 Plus, which can do, the frame rate kind of sucks if you go to really high res, but you can do up to 1080p if you'd like. You're not going to get a frame rate of above 1 hertz on our system. We're not an application processor, but typically what someone will do is they'll do this thing called virtual windowing, where you can actually try to detect the tag on multiple, like an image pyramid. You can try to shrink the resolution and then look for the tag at different resolutions, each being a subset. And then you'll get a much faster FPS around 20 frames a second. And then by doing that, then you would, you basically look for a tag at, you basically take the image, downscale to 160 by 120, look for a tag. If you don't see it, okay, upscale it, look for a tag again, and you keep doing that until you find that particular tag, and then you can kind of zoom in on it and track it. And so once they do that, then, and once they have that tag being tracked, you can kind of find that tag in a very high resolution image. And then as the camera gets closer to the ground, you kind of unzoom that effect. And by doing all of that, the system can find the April tag and then precisely land a drone on it.
That's neat. All this. Well, the April tag, the code is not trivial. How did you fit it in on a microcontroller? It's not trivial at all.
Yeah, it was.
Other things you want to do edge detection. Okay, big deal. You want to write a convolutional kernel, things like that. Simple image filtering. There are, it's no big deal. But April tag is quite involved. I don't know how large this thing is, but it is quite involved.
Well, it comes down to 15,000 lines
Wow.
of code. Yeah,
Okay.
yeah. It was actually a challenge to port that. It took me about 7 days, I think 2 weeks in total, but about 7 days of really hard debugging.
Yeah.
Um, Basically, there's all kinds of issues in that code in regards to when so we had to shrink all the math from doubles to floats because the whole goal of our system isn't necessarily precision. It's the whole point purpose is to get high level features onto a microcontroller.
Yeah.
Um, and so, going from doubles to floats uncovered different, situations where they would have an optimization loop that would try to get, point 0.000001 epsilon
Right.
on, accuracy. And when you shrunk the thing to from a double to a float, that's impossible. And you have an infinite loop in the code then. And you
Right.
just like, why is it stuck there? And you'd have to debugging that was a challenge. April tags actually, in order to be fast, it uses up way more RAM than it needs to. So April tags are effectively these codes.
Yeah.
And the fundamental concept is that they have this thing called, you have like this 36-bit code that looks like a 6x6. I have one actually here.
Yeah, it would be good. Yeah.
This is an April tag.
Yeah.
And so this is a 6x6 tag. So there's 6 boxes here, 6 boxes down, 6 boxes, 6 boxes. And what the algorithm effectively is doing is I'm not sure how much time we have, but I can define how this is what April tags does in a nutshell. April tags first will take the image and threshold it. So it does a thresholding pass, and this actually takes up most of the time. Like basically, as your resolution gets larger, most of like almost 90% of April tag's time is spent thresholding the image.
Wow.
And the default April tag algorithm does thresholding just using the CPU and not any complex fancy MMX stuff, or it doesn't use vector operations.
Yeah.
So the default algorithm is not that fast on a PC just because it's not using the best features available.
Right.
But for thresholding, what's basically going on here is it'll segment the image into no contrast areas, lots of contrast areas, and black or white in those lots of contrast areas. And that basically finds black pixels on the border and white pixels on the border region translations. The reason why it has those no contrast regions is so it can quickly ignore them. After it finds those, it then builds a list of pixels that connect, a list of points that connect around regions. And so it might say, okay, these are all the pixels in this black region that are touching this border, and these are all the pixels in this white region that are touching this border. Using that data then, it can kind of build out something called a quad detection. So the quad detection, there's a whole bunch more stuff going on. You have to like you have to sort the points by the centroid and then try to walk them to find corners. But basically using those edge regions, it'll try to find things that look like 4 points. So 1, 2, 3, 4.
Corners.
Yeah, once it finds those 4 corners, it can then do a standard homography. It can then work out the homography and then basically un-3D rotate the tag that's in 3D space.
Yeah.
And then rotate that to be a flat image.
Frontal. Yeah.
Yep. Once it has that, then it just does a simple line scan of back and forth of the tag's pixels, and then looks up and then tries to go to a lookup table to figure out what that tag is. Now, here's the memory wasting problem. In order to be fast, they didn't want to scan a lookup table in a linear format to try to find the closest Hamming match. Let me back up for just 1 second. So the tag has 36 bits. What that is called is it's a Hamming code. So there might only be, there's not actually 2 to the 36 tags. There might be only 512 tags. And what they've done is they've made it such that all tags are some number of bits distance away from each other.
It's error correcting for automatically making sure that there is no collision.
Yeah.
And the 36 comes from that 6x6 grid that you just mentioned.
Yeah. So this tag in particular is called 36H11. Okay. And what that means, the H11 means the Hamming code is 11. That means that all tags are guaranteed to be 11 bit flips randomly. So out of the 36 bits, 11 bits can randomly flip in the tag. and it will not collide with another tag. That's what that means.
Yeah. So very robust in that sense.
Yes, yes. And so, given if you scan a tag in the picture and you want to find what tag that is in your table of tags, you basically have to compare it with every tag in that table. Basically XOR the 2-bit strings, so XOR two 36-bit numbers, and then you count the number of bits difference. And if that is less than 11, then you found your match.
Yeah.
And then you keep track of the lowest one, which is the closest match.
Yeah.
That's slow though, because you have to do that per tag.
Right.
So what April Tags does is they compute all permutations on startup of 11-bit flips.
Wow.
And then they compute that again for another 10-bit flips. And so they allocate about 64 megabytes of table in order to have O to the N1 lookup speed.
But that's their optimization though. They are optimizing for speed.
Yes.
Not for memory or anything like that, right? So that's their optimization. Your choices would be different.
Yeah, yeah. There wasn't like a switch though for turning that off. So basically, I have to go into the library and more or less understand the algorithm that they wrote.
Yeah.
And then rewrite it and make it such that it does a slow linear search. The benefit though is all of a sudden you save 64 megabytes of lookup table that would have been allocated previously. And additionally, there's other things like the way in which there's something called union find, which they use to store a table of how they match image coordinates and like different edges together. How they track which edges are part of the same surface. And so they use 32-bit floats to store that 32-bit integers to store that table. If I say the resolution is less than, if we have less than 64K pixels in the image, we can store that in 16-bit numbers. There's just like a lot of different little optimizations I had to do on the code in order to shrink the amount of RAM it used from megabytes down to kilobytes.
Right. That's amazing. I mean, the level of dedication you have to make these things work on a microcontroller, that's amazing. I mean, I actually want to talk a little bit about the main, the Kickstarter campaign, how you built the OpenMV community, and how did you launch the Kickstarter campaign. And there was a big, fail after you launched the Kickstarter campaign, but you came out of it. So I want to hear about the whole deal, how you built the community, the Kickstarter campaign, and the Hackaday fail of the week, and everything. That's an amazing story.
Yeah. So I'll go ultra quick on that. More or less, when we launched the OpenMV Cam product, the sensor choice was this thing called the OV2640. It's like a decommissioned, I mean, it's not in production anymore, but there's just so many different modules floating around in the black market. You can still find it in plenty quantity. But all those modules, though, are defect grade, meaning they were like the units that, were rejected from the factory in terms of their quality. Anyway, so we decided to buy some of those sensors. They had been left outside, and the packaging says that you can only expose them to moisture for 24 hours before they start to corrode. We bought some that had been exposed to moisture probably for decades.
Wow. And you can tell by looking at these things, you cannot tell that these are micro rust or whatever, very small rust elements that you cannot see.
Yeah. What happens is when you try to solder the sensor onto a PCB board, it just fails to do that. It corrodes instead and creates a layer of oxide, which doesn't actually electrically connect. It's structurally intact, but there's no electrical current flow. And so you basically pump out dead on arrival devices.
How did you debug this? I mean, it's because you would see that, there's a connection if you visually inspect, even through using, a lens or something like that. How did you debug that there is no electrical connection?
Oh, yeah. So, I mean, basically we had our CM, you can use X-rays actually to see this quite clearly.
Oh, okay.
Yeah, so they'll have an X-ray machine that'll look at the cross-section of the bumps, and it'll be able to tell whether or not there was a failure to connect by the color of the bump underneath the chip, basically.
And 80% of the chips that you had ordered, they were bad.
Yeah, 80% of them. And so
Wow.
that kind of yeah, in order to kind of get the product out of the market, we basically had to take an approach where we had to charge everyone's shipping twice. We more or less used our shipping funds to restart production and pay for all of the lost components. And then by doing that, we were able to and then we had to generate hype.
Yeah.
So that was basically constantly coding, adding new features, making the system better. I will say, like when we first started working on the thing, it was pretty. The system has gotten, if you don't like the OpenMV Cam and you use it right now and think it's underpowered, trust me, it was much worse when it started.
Yeah.
We've continually though built up the system and made it less of a flaming trash fire. But when it first started, there was just like so many bugs to fix and everything.
How
Yeah.
much did you raise during the Kickstarter campaign?
So we did a pretty modest 100K, which was enough to get the production started.
100K is pretty big for most, first time product launch. It's a big amount. Yeah. And then the 100K, but nobody gets 100K by just launching a Kickstarter campaign. You need to have some sort of a community built to do a 100K Kickstarter campaign. How did you go about that?
Yeah. So OpenMV had actually been on this website called Hackaday
Hmm.
for quite a while. So Hackaday is a website where you have it's a blog about different electronics ongoings. And so Hackaday back in 2013 launched well, I think before that 2012 or 11 had launched this thing called Hackaday.io where they let people
Hmm.
put projects up. And the OpenMV Cam at that time was the most popular project on Hackaday. It maintains one of the highest like skull, like likes and
Yeah.
views and etc.
Wow.
And so there was a lot of interest back then for people wanting to see this kind of thing happen. Could you actually get a microcontroller to have computer vision, and could you do it in a way where it was not just one function but pretty flexible?
Right. Right. So that's where the community, you have been building the community for more than a year, or how much time? Uh,
I think the community had been under construction for about a year and a half, actually.
for a year and a half, and
Hmm.
they all came together to help you in the Kickstarter campaign. But after this, during delivery, the Kickstarter campaign was successful, but after this, the debacle happened, right? So how much was your shipping date pushed back?
I think we shipped like a year later or something. It was
Okay.
pretty bad. But your hardcore backers have tolerance for that, so we managed to get out the door. And then from that, we sold the M4 variant. It really wasn't that good, but it somehow managed to sell. I was surprised by that because as a
Are these
creator, what?
are these hobbyists, or also large companies who are ordering large volumes, or these are mostly hobbyists who are buying the cameras?
Yeah, right now mostly hobbyist
Okay.
and educational. This year has been hard for us because the educational market was kind of destroyed.
Yeah.
To be quite honest, during COVID, a lot of like the OpenMV Cam pretty much shines in competitive robotic applications where you have students and high school students and college students who are
Right.
competing with like making the fastest line follower or etc.
Yeah.
One of the nice things about our camera system is that the frame rate's rather unlocked. You have like direct register control of the camera, and you can do crazy things like change the readout window to increase the FPS beyond what the manufacturer wants you to run it at,
Yeah.
um, and various other things.
Do people run into weird problems when they try to hack those things like that?
Yeah, but I mean they're fun weird problems. Like
Yeah.
uh, an example being, did you know most camera sensors support a readout window setting where you can define where the readout area of the camera sensor is? And the benefit of that is if you change the readout window and you make it really tiny, the frame rate will typically go way up then.
Got it.
Um, like you can get into several hundred to 200 FPS easily with some cameras if
Interesting.
you make the readout window very small. Typically, though, that's not a setting you'll ever be able to touch, though, if you're kind of running through, standard Linux drivers for a camera, just because it's not expected you would want to do that to have, quality, video that's good
Right.
looking. This is like weird, crazy stuff.
So people do that kind of thing to, let's say you have already detected a face, and or detected an object, and you know that the object is not moving that fast, so you can read out only around that object. It's almost like tracking. So you're reading out a smaller area and then tracking that object very fast because now you're at 200 FPS.
Yeah, and we have an example of that with our OpenMV Cam H7 Plus. So this is a 5 megapixel camera sensor, the OV5640, and it has readout window control. And so we have an example of it doing IR LED tracking, where we can track at 100 FPS and IR LED in a basically a 2592 by 1944 pixel region. I think it does a little bit higher than 100 FPS, but our camera sensor driver isn't quite at the final level of optimization. So like an example of like super huge deficiencies and somehow the product has managed to sell was our camera system data pipeline only accepts one image at a time. We do not do double buffering. Right now I'm working on getting double buffering out in the market. But we've been able to kind of survive basically where our camera only runs at half the frame rate it's capable of doing, just because we only have one image data buffer. And so, if you're working on that, you can't accept a new image. With double buffering, our software architecture will then be allowed to accept a new image while it's processing a current one. And that allows you to double your frame rate, more or less.
So with no additional, your same code that you had written before is going to now run twice as fast with the same processor and everything.
Yeah, with the same processor and everything. We never did it originally just because we've always been RAM limited. So like on the Plus model, we added 32 megabytes of SD RAM, and we're getting requests from people now that basically say, hey, given you have all this extra RAM, you can, store 2 images in RAM now. Can you please enable that feature? Thank you. And also stuff like, so like when you want to record video, for example, typically you have to deal with something called like SD cards, for example, will randomly block writes for about up to half a second while they're doing erases. And typically all Linux-based systems have a huge RAM buffer in order to buffer all the writes being sent to an SD card in order to hide that from you. And so we're going to implement something similar, which is a video FIFO in RAM. And this will basically allow the camera to collect about maybe 30 to 40 frames in memory, and then write those all quickly to the SD card once a erase finishes. But this will also give you the ability to do things like smooth video recording, just like a commercial Linux system will do.
Right. So now what fascinates me really is this, you're doing so much, you ran this Kickstarter campaign, everything, and OpenMV is still your side project. It's not your main day job. How do you manage to get so much done? Most people have difficulty just keeping a single job. So what is the time management looks like? What do you do? What do you not do? How do you get your time back and devote it to this project?
Yeah, well, it really depends on what makes you happy. I like being of service to others and helping people. And so I get the most energy from kind of doing that kind of thing. I guess the best way to say it would be like I used to be into video games, 30-year-old guy. So that was what I grew up with. But those aren't fun for me anymore. I've kind of already experienced all the standard plots and tropes. And so I don't really want to do that. TV is good, but I never feel like jazzed or super energized necessarily after watching TV. I mean, I did watch The Last Dance with Michael Jordan, and that made me feel super pumped. So documentaries, I still really like those, but I've kind of gotten over just watching random, action flicks where things explode and, strong He-Man guys go around punching people. It's, those are, that's what TV, there's a lot of different things to watch and consume and use your time. But you can be a little bit more focused that instead of like unwinding watching TV, you can kind of think about how can I whittle on a little block a little more and make that better and see what I can do with a few hours here and there that I would normally just use to like unplug and, that you would normally zone out typically.
Yeah, so I do something similar. I don't watch TV. That's not even, it doesn't even bother me. And sometimes all the TV I watch is while doing exercise, and that's not too much. So Yeah, so that's it helps me focus. But one important thing that I do is I don't watch news either, which people think, oh, you will be uninformed. I said, what difference has news made to your life? Tell me.
Oh, that's so true.
Right.
I mean, it's a reality. It's like you can't change or affect any of those decisions.
Yeah, and it has an after effect that you keep thinking about that news item long after you have finished reading the news. So I was reading the news mostly on weekends. I'll spend a couple of hours on the weekend reading the news, but with this, in the last few like last couple of months, things got so busy that I don't even read the news during the weekends as well. So now it's when I scroll, I do, go on social media. So when I scroll through my social media page, that gives me enough information what is going on. The headline is enough. What happened to the world. So
Yeah.
that's an important way to save time.
Yeah, and it comes down to also like having a good, healthy exercise habit. So, at least for me, what I've learned is when you start like letting your body slip,
Mhm.
it will cause your energy levels to go down, which will hurt your ability to actually like continue working hard on things. Like if you get tired at late at night, and you're like, oh yeah, I need more sleep, but I'll be better in the morning. Then you wake up late, and it's like I didn't sleep enough.
Right.
It really is just like you just need to exercise more to build up your internal energy levels. And once you can kind of put yourself in a regimented regime, you can be a machine. I don't
Right.
necessarily say I want to do it all the time. I mean, I've been picking up things in COVID like golfing. Um, so trying to get out into the green and putt and do other things just to keep my mind sane.
Yeah.
Um, but yeah, it's all about finding that healthy work-life balance and kind of sticking to it more or less.
Yeah, yeah. So tell me a little bit about your childhood and growing up. What influenced you to come into robotics and machine learning, etc.? Did you have any early influences which propelled you into this?
Um, I would say yes. I think the big things that I played with originally when I was a kid were Lego.
Hmm.
So Lego, makes engineers, right?
Yeah, that's true. That's true.
But also there were these electronic kits back in the day that you soldered up that did really basic things. I forget the name of them, but an example would be they'd have one PCB board, and the PCB board have nothing on it, and you
Uh-huh.
would literally build a robot's brain, like motor drivers, a simple like set reset latch logic gate. And
Right.
I think this robot did this. It would drive straight, and when it hit something, it had a microphone that would make a impulse when it ran into a door, and
Uh-huh.
that impulse would then trigger a set reset latch for it to back up. And then that
Nice.
set reset latch had like a capacitor that would decay in power. And so it would back up for so long and then it would run out of power and then it would go straight again. And so all it would do is run into something, back up, go straight, run into something, back up, go straight.
Yeah. Yeah.
But what was cool is that you had to actually build that using literally electronic circuits. You had to
Yeah.
understand there was no processing on board. It was literally
Yeah.
just analog circuits and a few digital latches in order to
Right.
get that behavior. And from there, I got into the basic stamp back when it was first out. This was like a little bit before the Arduino was really taken off, and that was my first experience like playing with microcontrollers, and it was wonderful
Yeah.
because it was the first time I could like make something do something of my own will.
This was at what age? How old were you?
High school.
High school. Okay. And then
I wasn't really like following this stuff. I was more into just like standard childhood things like playing games, hanging out with friends before this.
You went to Carnegie Mellon for your undergrad as well as master's.
Yes, yes.
So what was the process like? What got you interested in electrical engineering at Carnegie Mellon?
Well, I started off at doing electrical engineering originally.
Yeah.
Um, I would say I didn't have the best, I didn't come in like as a superstar at all in school, but I was determined to work hard and try to go somewhere. Um, the guy who really helped me was Professor James C. Ho, and so he basically took me under his wing, gave me budget to work on research projects, and more or
And
less
this
I
was
got
your undergrad. This was
yeah,
when you were in your undergrad. Okay.
yeah. Typically, undergraduates can go to school and they can sign up to like do research stuff. Um, it's
So
it
you
is
just
kind of
talked to
a,
this professor. How did you make a connection? A lot of undergrads would
yeah.
just spend the time doing, undergrad stuff, right? They won't
Mhm.
even think about approaching a professor to actually, I want to be part of your research lab, because they would be shy. They may be thinking that they do not have the capability to pull it off. Uh, how do you do that? Like as an undergrad, what did you do?
Well, Intel was actually a big help for this. So back when I went to school at Carnegie Mellon, Intel was running something called not the Intel Talent Search. That was their big competition. I think they stopped doing that.
Uh-huh.
But Intel, it's like Scholars Fund or something. I forget the name, but basically Intel would give you a stipend.
Uh-huh.
So they'd pay you to do research. So
Yeah.
it's like a school, job basically.
Right.
And more or less, it was not competitive at all because most people didn't care to actually do research at school. So
Right.
I just saw it and said, "Oh yeah, they're paying money. Okay, I dig that." And then I applied, and they didn't. They just looked at They just looked at, this is what you do. It wasn't based on what you had previously accomplished. It was just like, "Oh hey, he's in ECE. He's a freshman.
Right.
Let's Here's a list of professors. Pick one off the list." And I saw James Ho was like FPGA stuff, microcontrollers, and I was like, I'm gonna go ask him. And that's literally how my path got started.
Yes,
Very
so some of it is luck. You just happen to be with the right professor who helped you a lot, right?
Yeah, yeah. It is definitely luck. I could have picked any other professor on that list,
Yeah,
and some of them may not have had time to bother with me. So
right. But it's
yeah.
also initiative. A lot of people in your situation may not even bother approaching a professor or applying to this kind of. So that's for somebody who is an undergrad at this level, right? People who are interested in AI, interested in maybe edge AI.
Mhm.
How should they, maybe second year undergrad, maybe they are in sophomore or something. What recommendation would you have for them to uh, enter the field?
Yeah. Two words: get good. No. um,
There's this book. I really like this book. There's this book called "Be So Good They Can't Ignore You," and this is by Cal Newport, who is a
Mhm.
professor at MIT, I think. And he has another book called not deep learning, but something like that. Deep work. Yes, deep work.
Yeah,
Um,
well, it comes down to, if you're really getting started in the field, um, you really should do, there's two ways to think about. So if you're in school, one of your primary goals that you should try to do is get that basic education of how things work. The mark of a good engineer is typically one person who wants to understand as much as they fundamentally can beneath the hood.
mhm,
um, you shouldn't enjoy mystery. So if you're like, hey, I'm going to leverage OpenCV and I have no idea how these algorithms work fundamentally at any level,
mhm.
that's not the best.
Right.
You should try to really have some understanding of those algorithms, and re-implementing the wheel is not bad. You
Mhm.
don't necessarily want to do it all the time, but if you understand things from a really core competency level, it'll really help you leverage and go faster for bigger and greater things in the future.
Yeah.
Um, Not to say you need to re-implement all of OpenCV in your undergraduate, but I'm saying, like, if you are taking classes to understand these algorithms, it's really helpful if you actually know how to code them by hand.
Yeah.
Just a few of them to get some knowledge of how these things work. Like reading April Tags code, for example, made me 10 to 15 times smarter just because I saw all these different tricks
Yeah.
that you would use in computer vision and linear algebra and various things and so on and so forth. If I had never like gone through that code though and ported it,
Yeah.
I would have never like been exposed to all these different things the code was doing. If I
Right.
only like worked at the toppest, the highest level, I would only be gluing things together. And so it is good for you to kind of reach in these black boxes and try to figure out how things actually operate.
Yeah.
Um, and then at the same time, I would also say, uh, your education you'll receive at your university is there to is there to give you a resume saying you were educated. You shouldn't depend on what your university or institution gives you as being the only education you can get while you're there.
Yeah.
Um, So make an effort to really do your own projects and build your own things in your free time. It'll definitely help you get beyond and push your abilities into new levels. Never get comfortable, I would say, with technology is always changing. Things are always changing. Try to learn as much as you can, and then implement that in practice, and build your own things and see what can happen. Like, um, I had an operating system and design course, and so one of the things I tried my hand at was building my own operating system for a microcontroller.
Hmm.
It was not very good, but I learned a lot of things about how that would happen, versus how that would happen on a on like I learned in class how that would be built on a computer, with a memory management unit, and then I tried my own hand at doing that on a microcontroller. It had no commercial retail value. It didn't have anywhere
Yeah.
to go, but it was a project that I tried to build just to understand more.
Yeah, that's a great strategy. If you build to understand, it really clarifies, because you cannot cheat there. The things that you don't understand, you cannot code. There is no cheating you can do. You cannot sweep anything under the rug. For embedded vision, or the kind of work that you're doing, are there any books or courses or blogs that you think are useful? Not just general computer vision. I know there are a ton of blogs, but specifically for the kind of work that you are doing with microcontrollers.
I don't think so. I mean, so OpenMV's not. I mean, we're kind of popular. We've sold like 40,000, probably 50,000 units now.
Yeah.
It's kind of hard to know the numbers because we get cloned a lot. We opened our software and our hardware designs open source, and so there's a huge market of clones that I don't sell that are out there, especially in China. But
How do you feel about that? I mean, the whole reason you open sourced it is that so that somebody can clone you, but at the same time, that profit could have been yours. How do
well, no, the open sourcing wasn't so you can clone me. The open sourcing was there so you could remix it into a product.
Oh, got it. Yeah.
One of the things with the OpenMV Cam that's different from the Raspberry Pi is that our processor is actually available, is sold on DigiKey and Mouser and is available in quantity one. So realistically, you can buy our processor, take our code, and build a commercial product on it,
Uh-huh.
without having to have us in the taking a cut of whatever you're selling.
Yeah.
My goal isn't to have zero revenue from that per se, but it was to kind of unlock situations where people could build things using microcontrollers because there'd be a code base for them to start with versus building it all by themselves. But
Right.
there are different people who look at that and say, oh hey, no, we can just copy the product directly, and they produce the exact
Yeah.
mirror of it, which competes against my product. That's been happening a little bit less now. There's a new Chinese processor on the market that kind of like they didn't clone they don't clone the hardware anymore, but pretty much the whole software development environment, along
Hmm.
with the software, the whole concept of what OpenMV is now being cloned,
Uh-huh.
but with different hardware. Still using my software IDE, so you can find our IDE has been rebranded and changed into Chinese and
Right.
sold with a different product.
Right.
Um, super great, but that's what I'm here to.
But in your licensing, could you have written something that it is open source, but if you're using it for commercial purpose, you pay some licensing fee? Was it possible, or is it not enforceable?
It's not really enforceable. I mean, at the end of the day, all those things you have to actually have legal power to go after somebody, which we don't. Additionally, we leveraged for our IDE Qt Creator, which was already GPL, to build our system. And
Yeah.
so the cloners also keep their software open source too. So they're not violating any licenses.
Got it.
It's just poor taste a little bit.
Yeah.
But I don't want. I mean, this is what it is. I'm happy. I should accept it as it's I guess flattery that someone thinks my idea is
It
actually
is.
valuable.
I completely agree. When somebody copies your idea and clones it and even builds a business around it, it is real flattery. It is, your engineering has succeeded at some level.
Yeah, yeah. And so, for a general trend for microcontroller stuff, right now we're really on the cusp of that. So what I've been doing so far is really proving to the world it's possible, but a lot of the applications we have are kind of underpowered, and we work really well in a few particular scenarios, but it's not like a knockout hit like OpenCV with a Raspberry Pi everywhere.
Yeah.
That's going to start changing though a little bit in the future because I'll say like silicon manufacturers are starting to get understandings of how many devices they can deploy in the market
Yeah.
and what kind of revenue it's possible for them to make by developing a future where it is possible to cheaply deploy cameras trivially into literally everything.
Yeah.
And so you're going to start seeing in the next couple of years really stupendously powerful microcontrollers start arriving on the market. About 100x performance in terms of what we have now, within a few years, basically.
And most of it is driven by the cost consideration and the form factor consideration.
Yeah. So, the concept of, so right now, this little guy right here, this processor is running at 480 megahertz. And it, does it can do basically 4 ops per clock cycle. So you're maybe hitting 2 gigaflops,
Right.
a little bit less than that. And that gives you 6 FPS person detection. That's going to be 100x in a few years.
Right.
And at that point, then this little, device, the size of a quarter, is going to be, the same footprint. It's going to be able to basically do, a complete computer vision solution where it's tracking multiple people instead of just like person no person.
Yeah.
It'll be full bounding box image segmentation on all the people in the field of view, and tracking them like we see a NVIDIA GPU right now doing.
Right. That's amazing. I mean, I hear a lot, because these things are so low cost and low power, the market for these things is huge. People would put it in stuff which maybe doesn't even require, it's not, there are no obvious uses. I read somewhere, maybe some interview of yours where you said that, a toaster could have one of this, and it's not unconceivable when the price goes down substantially, right? These things, every one of these can start having these microcontroller-based vision solutions.
Yeah, an example would be, imagine your fridge, right? If we've reduced the cost of a compute and camera with deep learning down to less than $10 per unit.
Yeah.
Okay, let's just slap a camera per level of your fridge.
Right.
Right now, everyone thinks about, we can only have one camera because that camera and compute's too expensive.
Yeah.
So we gotta have one camera. It's got to do everything. We got to do the most perfect lens correction, somehow get everything into the field of view. How about we just solve it with just throwing more cameras at it? And so you can imagine, okay, now your fridge has a camera per side of the wall, or even 3 cameras, on each level. And from that, it can identify all objects within the fridge and then literally tell you when you're home or away what's in your fridge. So you know what to buy. A stupid application, but there are all kinds of really cool things where once we can kind of drive that price of compute and sense down to a ridiculously low level, that's where we start having cameras then become a commodity. And instead of them being treated as this ultimate sensor that requires the ultimate compute package, they're treated more of as this throwaway sensor that we can use for random whatever applications.
So the people who want to help you with OpenMV, how can people, it's an open source project, so people can just go to GitHub, contribute to it through a pull request and stuff like that. Is there any other way? Is there a forum that people can join?
Yeah, so we've been running for about 5 years now. Basically, we have an online store where you can buy our camera system. It's just me and my co-founder Ibrahim, and we have 2 partners in China who we work with. It's really not a big team, but we've managed to go pretty far. We also have a software optimizer we hired this year, Larry Bank, who's helped us increase the performance of some algorithms by 1,000%.
Right.
Wow. A lot of my stuff was naively coded, just because I didn't have time to really think about what's the best way. And
I just want the audience to know that you are very down to earth, and you try to downplay a lot of work that you have done. some of the things that you have done, they are spectacular. Like putting April tag to a microcontroller, but the way you say it is as if, oh, it's nothing. So I just
Well,
want the audience to know that there is a
well,
little bit of that going on here.
I think that was one of the most impressive things I did. But there's other stuff like I wrote a median filter where I did the naive example of computing given a neighborhood of in by in neighborhood, I would compute the histogram for each neighborhood and then sort it
Ah,
and then
right, right.
repeatedly do that. And so our software optimizer came in and said, oh, that's bad. And
Yeah,
instead, he has a sliding window histogram. And the performance difference was if you did a 7 by 7 neighborhood,
yeah.
you would get maybe 2 FPS, and he increased that to 17.
Wow. Yeah,
Um, just like stupendously huge gains. And
yeah, yeah,
now the OpenMV Cam supports a median filter where you can do like a 21 by 21 median filter on a 320 by 240 image and still hit above 10 FPS on this microcontroller,
very
um,
cool.
which is before that would have been within like it had been like maybe 5 seconds per image or something.
Yeah,
So anyway, um, yeah, so basically, we have a huge corpus of computer vision algorithms that we've kind of ported over. It's kind of similar. I'm not sure if OpenCV's roots were it was kind of like really focused, or it's become like a mixed bag of people, sending PRs and just getting better and better. Like,
it is still based. The core team is at Intel, and so there is
mhm,
a push towards making it faster and faster for all the Intel processors. But we also do Google Summer of Code, which adds in features which are completely new features. And then we have collaborations with other companies where we do optimizations for other processors like ARM. So it's a mix of, there is a consistent effort to make things faster on things. Like the DNN module is something that everybody is interested in, and everybody wants to make the DNN module faster on their processors. So
mhm,
that's a big focus right now. But there are also pretty random applications that get added during Google Summer of Code, which is very nice.
mhm.
uh, these uh, these are rich applications. They make the library so much more usable, and not just performance based, but also the quality of applications, variety of application is also
Well,
very.
I was talking about more like so when OpenMV basically we've just been adding random features that people ask for.
Yeah,
And so, like, I would say there's never been like, this is what the library should have in it kind of thing.
that's been true with OpenCV as well. Like OpenCV, when I was a grad student back in 2001, I used it for two purposes. One, to read, write image, videos, etc. That was very convenient.
Hmm.
And the second thing was face detector. Anywhere I wanted a face detector, the OpenCV face detector was available. So those were the two killer applications. And after that, things just kept getting added. And every once in a while, the library is reorganized. But that's the approach, because we don't know, what the whole. You cannot you cannot have a very you cannot have a plan to implement all the different algorithms, because it completely depends on what the users are desiring, what they want implemented in the library. If you try to do it yourself, you would end up implementing some good algorithms, but nobody uses them, right? That kind of
Oh,
situation.
yeah, yeah. No, we've done that. Like, originally, I was trying to update OpenMV to have as many features as people needed to kind of mirror all of OpenCV's functionality, and then I realized that's
Yeah.
impossible. There's too
Right.
much stuff in there.
Yeah.
And then I realized I had added a bunch of stuff that people actually never use, and so
Mhm.
there's a bunch of like garbage in our library right now that kind of needs to get thrown away.
Yeah.
Um, what I plan to do moving forward is really focus, on things that are really useful. So mirroring OpenCV's image processing module, which is like the core
Yeah.
functionality that OpenCV, most people use,
Yeah.
followed by really leveraging TensorFlow Lite for microcontrollers for deep learning.
Yeah.
And then we also have someone bringing on support for NumPy effectively. So
Oh, wow.
yeah, there's a
That would be
library
awesome.
called, oh yeah, yeah, there's a library called ULab, and it is effectively NumPy on MicroPython.
Wow.
And it doesn't have all the necessary integration features yet, but once it's done being fully supported for our image array type, this will let you do NumPy-like matrix algorithms on images, more or less, on the OpenMV Cam. And
That's
so if you know, like, if you're really hard code NumPy coder, you can basically write all of the matrix ops to happen on the OpenMV Cam and have that running on a microcontroller.
That's cool.
But yeah, but anyway, the way people can help us is, you know, we're always like, it's just me and Ibrahim, and I have to kind of run the company to keep OpenMV afloat.
Yeah.
And so, and then also like work on different things like an interface library for the Arduino and et cetera. And then primarily driver development takes up all my time because that's really, really hard for anybody else to do if they don't have the necessary tools or understand the architecture.
Yeah.
But we're always looking for help with anyone who wants to contribute to the image library and really round out features that we're missing. Like all of our drawing algorithms are, you know, non-anti-aliasing. You know, send a PR to update that to anti-aliasing.
Have you tried actually applying for Google Summer of Code and getting some interns?
I haven't actually. I didn't know that was an option available.
Why not? It is available. You know, you just apply and they may choose you. They will choose you. I'm pretty certain.
Okay, I'll do that. We did apply for GitHub sponsorship, and that is, I think we've got like maybe $200 a month or something to help out with that. It's not really like, most people don't want to do that. So
yeah, Google Summer of Code is huge because they give you, you know, an intern and they pay the intern well. So even if you get 2 or 3 interns, that can completely, you know, fast track some of the algorithms, some of the work that you're doing.
Well, one thing we want to do that's really big is, so, you know, OpenMV, like me and my co-founder have never really had time to kind of like port the library out as an external module. So right now we have a few different things coming into play for our code base. There's MicroPython, there's the STM32, and then there's our library. And all of them kind of blur a little bit in their functionality being combined. And so what's hard is for you can't really take our image library as a module and just put it into another system without editing a lot of different pieces of code.
Right.
And so one thing I think that'd be really helpful for us is if we could actually split our image library off completely from being integrated too heavily with MicroPython and our STM32 in particular. We did, luckily, Ibrahim, my co-founder, had the foresight not to directly inject a lot of MicroPython into our image library. So our image library does not depend on MicroPython, but there's a lot of STM32 specific things going on in it.
Right.
So one of the things we'd love to do is kind of break that into its own separate module such that there existed finally a binary level, a library that you can compile in C for any microcontroller to then get computer vision basically added to it.
Okay, cool. So people can simply go to the GitHub repo, join your forum. Do you guys have a forum on?
Yeah, we have a forum. It's not on GitHub, but it's we chose to put up a PHP v3 forum. And the reason for that is Google can index it. Thus, when you want to ask a question, instead of, like, a lot of people are doing Discord-based forums or Slack-based forums, but those are impossible to index by Google.
What about Discourse? Discourse. What about Discourse? Discourse should be indexable by Google, isn't it?
I mean, it's too much momentum right now to change the PHP forum.
Yes.
Because it's like work, but you know, when we started though, that was we tried to copy how MicroPython's forum was done, which was PHP BB also.
Cool. So, and what is the best way people can reach you?
So OpenMV is a company. We created it in order to you know, basically get the OpenMV cams on the market. It's kind of hard to sell a product if you aren't that. So we have a website, commercial email address, so openmv@openmv.io. You can sign up for our email list. We post updates when I have time. We have a Twitter hashtag. Well, it's @OpenMVCam. We do not actually own @OpenMV. That's owned by another account. But you can do hashtag OpenMV to kind of hit us up. And yeah, I mean, we've been around for a while, so we've got products on sale. on SparkFun. If you're in the USA and you want to buy from there, we have a we have a partner in China called Singtown you can buy from. And then we have various distributors all over the world who hold our products that you can buy and play around with.
That's awesome. And are you going to do the do a Kickstarter campaign for the micro camera that you showed?
Well, we're probably just gonna, it's actually really cheap to make. So we're actually probably gonna be able to pay for it out of pocket and do a production run of about 1,000 units without even needing Kickstarter.
Right.
So this module, basically it comes in a little case, a little window. The case has turned, this plastic was cheap, so it was white. It turned yellow from being exposed to the sun. But once we get all the bugs out of the micro, and by the way, the micro does auto rotation, so it has an IMU behind the camera, literally located directly behind the camera. So when you rotate it, like a cell phone, you can automatically rotate the camera field of view using the gravity directional force to figure out, which way we're pointing. And that'll also be helpful for like visual odometry things, I guess people can think up and whatever.
Right.
But the
that
micro
would be out this December, by December, right? The production version?
Can't say. It'd be nice. Funds have been tight, to be honest, with COVID.
Yeah.
Different production run schedules are down. We did, Joe, just pay for a remanufacture of literally everything in stock.
Yeah.
And so we managed to pay that huge bill. The hope is that we'll be able to actually announce a kickoff and new production run of the micro probably in December or January.
Yeah.
And we'll probably just go directly to building 1,000 units and then putting it on the store and trying to sell it from there. And one thing that's nice about it is for features for it, the whole purpose of this device is that you can plug it into another microcontroller easily to have it be commanded and controlled by that. So we have a remote control library that's going to let you basically talk to the camera over I2C or async serial. And over that, then you can command it to do different things. So you can tell the camera, hey, I want you to track, April tags, and then you can get that data over I2C on where the April tag detections are. And our RPC library, it's called Remote Procedure Call.
Yeah.
It's actually quite flexible. So this will let your main processor do something like ask the camera detect April tags. The camera will then detect the April tags, and then it can return a JSON list of every tag in the image. Yeah. That list will be serialized over the serial link to another processor, and then that other processor can basically take that JSON string and decode it to get the exact same object representation from the camera of what the camera saw. So it's a lot more featureful than if you've ever used like embedded devices. Typically when they say like I2C or serial interface, it's typically like a register mailbox kind of thing where you can get like the XY position of one tag. And it's very limited on what you can do. This is we kind of designed our RPC library to be a full-featured data link, so that you can move anything over that link. You want to ask for an image? Sure, you can get a JPEG image over that link if you feel like. If you want a JPEG image plus all the April tag detections, you can get both at the same time. Whatever you feel like coding up, we support.
Right. That's very nice. So I wish you all the best for the new camera. And it was such a pleasure to talk to you. I have wanted to talk to you for a long time because, embedded vision is something that I really don't know much about. And it is great to know from somebody who has done so much. And also, your experience. We are learning from your experience. Brandon, who is the chief architect of OpenMV AI Kit, he thinks of you as a mentor, and we are learning, don't make this mistake because Kwabena said that this is not a good idea. So your name comes up in our discussions quite a lot. And there are things that you directly tell Brandon, but there are other things that we learn by watching your videos online. Some videos where you warn that, don't do this, don't do that. So it's been very useful, especially that Hackaday fail of the week. It's such a big learning experience. We learned from the mistake that happened in your case. And we also were inspired that in spite of that debacle, you just came back in a very big way, and you actually delivered the product. So, and we are in that stage right now. We have to deliver our product. So it gives us a lot of inspiration, a lot of hope.
Yeah, yeah. No, I think OpenCV AI Kit is amazing, and it's going to be super powerful. And Luxanis and Brandon, they know what they're doing in terms of hardware design. I have a few of their other products.
Yeah,
I didn't know what I was doing when we did our design, but it helps to have quality board designers on staff.
yeah,
But there's always like pitfalls though, and choosing the right sensor, and making like building hardware is difficult because there are like real constraints on where you can buy things from and
yeah.
when you can buy it and how much you can buy. Like,
Yeah, and in your case,
yeah.
it was not a design fault. In
Mhm.
your case, it was one of these weird things that you found a good sensor, a good chip, but it was just, it had this weird quality that it was out of commission and things like that. So it was not really your fault, but you still have to bear the responsibility, and you did. And
Oh yeah, yeah. Well, I mean, so you guys will find out about shipping soon. So one of
that's
the
true.
things is that when you're a manufacturer of hardware, when you ship a product, right? It's your fault if that product doesn't arrive, and you got to refund the customer no matter what.
That's
even
true.
if even if you handed it to the shipping company correctly and you wrote down the address correctly and everything on your side went well, if that shipment happened to get robbed by pirates
Yeah,
on the way to a customer, it's still a refund from you to that customer because their product didn't arrive. So
yeah,
there's
that's
all
true.
kinds of fun things going on when trying to sell products. Yeah.
Yeah, and especially these products get stuck at custom for some time, and those kinds of things happen, and it's difficult to know where things were lost.
Yeah, like one of the issues with selling, hardware that doesn't come with a case, for example, and a box that like pretty pictures and making sure it says consumer,
Yeah.
effectively in big words, is that custom officials typically will look at that as this is contraband. Um,
Oh wow.
yeah,
Fortunately,
yeah,
fortunately, ours will come in a case. So finally, you
yes,
know,
because you guys raised $1 million
yes,
plus dollars, yes,
yes.
but
So
it's
that
still
was the
like
goal.
make sure then to put that in a box that has like some labeling, like OpenCV, and it's all in a white box with
Yes,
all the regulation stamps of what it's been passed and everything. Just make it as consumer as possible.
yeah.
That's the best way to get through customs. OpenMV cams, we spend a little less on packaging. I just put it in an anti-static baggie with a barcode on it.
Uh-huh.
Um, but yeah, having those things though do help.
Okay.
Mhm.
That's good advice. That is something only people with experience are able to advise us on.
Yeah, an example. Here's a footnote. Like, my co-founder lives in Egypt,
Uh-huh.
and I have to ship him hardware every now and then, and it's a challenge to do that. That's all I'll
Because
say.
okay, because
Like
of
customs,
regulations?
what?
Because of customs and regulations?
Yeah, yeah. If you ship him an OpenMV cam, they will sometimes impound that.
Wow. Wow.
Yes. Anyway, it's been good talking to you, Seto.
Yeah,
Satya,
same
sorry.
here. And yeah, let's stay in touch. Thank you so much for making the time for this long interview. But I'm glad we covered a lot, and I'm sure that our audience will be inspired by all the work that you have done. And OpenMV will probably get a few new people who would work with you.
Yeah, and I just want to leave with one thing. So, we're looking forward to hopefully working closer with OpenCV in the future, just to enable computer vision more on all the embedded devices that are going to start appearing in the future, and just for everyone to keep an eye out on, the I don't know what the terminology they would use for like the TinyML community or whatever, but like ARM would say the fifth generation or the sixth wave is coming.
Right.
But basically, we're going to see in 2020, really in the next 10 years, the stupid high volume integration of really ultra powerful machine accelerators for all different types of AI applications and literally everything. And so we hope at OpenMV basically to enable folks to make that a reality and make it easier for folks to see this new wave of deep learning and computer vision devices being integrated into all sorts of random trivial things.
That's great. That's great. Thank you. So we'll keep in touch. Bye-bye.
Okay.